Hello students, I am Saili Rathod. Today I welcome you all in the video number 9 of video series of electrical measuring techniques. So in this video series we have covered the first unit of the electrical measuring techniques. Up till now we have studied the basic concepts about the measuring instruments. We have learned the static and dynamic characteristics of the measuring instruments. After that, we have studied the essentials of measuring instruments, that is, what is the essential part of the measuring instrument. Then we have studied the torque, what are the different types of torques, which are the different spring control and gravity control techniques in the controlling torque. So all these points we have covered up till now. Now in today's video we will start with the new topic, that is PMMC, its working, advantages, disadvantages and applications. Okay, so now we have to study both the PMMC, that is permanent magnet moving coil, and the MI, that is moving iron instruments. So we have to study both these types of instruments. We have to study the working and advantages, disadvantages and applications of both the instruments, that is PMMC and MI. So in today's video we will see the PMMC, and in the next video, that is video number 10, it will consist of all the details related to MI instruments. So let's start with today's topic. First, the PMMC. So what is actually the PMMC and on which principle does it operate? So the principle of operation of the PMMC, it depends upon the Fleming's left hand rule. Okay. So what is the principle of operation? When a current carrying conductor is placed in a magnetic field, it experiences a force and tends to move in the direction as per Fleming's left hand rule. Okay, it means whenever a current carrying conductor we are using, then the directions of the current and the magnetic field, it depends upon the Fleming's left hand rule. So for this purpose we should know what is actually the Fleming's left hand rule. So the Fleming's left hand rule, it states that from the diagram here we can see the left hand, in which if we place the three fingers in 90 degrees to each other, then the thumb will show the direction of the conductor, first finger will show the field and second finger will show the current. Okay, so we will see this rule in detail. In the first and second finger and the thumb, if the first, second and the thumb of the left hand are held so that they are at right angle to each other, then the thumb shows the direction of force on the conductor. The first finger points towards the direction of the magnetic field and the second finger shows the direction of the current in the wire. Okay, so this is about the Fleming's left hand rule. So using this rule, the PMMC is designed. It means the principle of operation, it is related to the Fleming's left hand rule. So this is the basic concept. After this we will see actually how the PMMC works and what is the actual system of PMMC. So first point is, it consists of a powerful magnet, shoe magnet, a light rectangular coil of many turns of fine wire is wound on a light aluminum former. An iron core is inserted inside the coil to reduce reluctance for the magnetic lines of force. The coil is mounted on the spindle and acts as the moving element. Okay, so when a rectangular coil of many turns and the turns are of fine wire, they are wounded, means they are in the form of spiral, we have rotated it around the aluminum former, So in this type they have designed the PMMC, in which again an iron core is inserted. Iron core means a core of iron which is inserted inside the coil. Why it is inserted? Because the reluctance should be reduced. So for this purpose a iron core is inserted inside the coil to reduce reluctance for the magnetic lines of force. Okay, so this is just a theoretical concept. When we will see the actual diagram, you can get the all these concepts. So second point is two phosphor bronze spiral hairsprings are attached to the spindle. The springs provide the controlling torque as well as they act as incoming and outgoing leads for the current. Eddy current damping is provided by the aluminum former. Okay, so this is the construction of the PMMC, and this we will see actual in the next diagram. Here again the construction, here it is described that a coil of thin wire is mounted on an aluminum frame positioned between the poles of U-shaped permanent magnet, which is made up of magnetic alloys like alnico. Okay, so the permanent magnets, they are in the form of U shape. Okay, so U shaped permanent magnets, and between these two poles of U shaped magnet the coil is mounted. Okay, coil of the thin wire, it is mounted on what? On an aluminum frame, and it is kept in between the poles of U shaped permanent magnets. The second point is the coil is pivoted on the jeweled bearing, and thus the coil is free to rotate. So the coil should get rotated when the actual field will be applied on that coil. It should get rotate. So for that purpose it is not fixed at that point, it is jeweled on a bearing. So why we use bearing? Because it should get rotated easily according to the magnetic field which is applied to the coil. So the current is fed to the coil through spiral springs, which are two in numbers. So two springs are used. In this diagram we will see the coil which carries a current which is to be measured moves in the strong magnetic field produced by the permanent magnet, and a pointer is attached to the spindle which shows the measured value. Okay, so we will see these points in the diagram. So here in this diagrams there are two views. In one we can see the top view, and in one we can see the side view. So in the above diagram we can see the N and S. N and S, these are the north pole and south pole of the magnet. Permanent magnet it is used. It is kept in the form of U shape. So as it is a side view, you can see only north and south poles of the magnet. So between north and south pole, between both these poles, the core is kept, and on a jeweled bearing the coil is pivoted, means it is mounted on that jeweled bearing. Now here we can see one bearing balancing weight is connected here and one spring. So both these are connected to the coil, and here we can see the pointer. Why? Because as this is a measuring instrument, so according to the electromagnetic field applied on the core, it will give the output and it will move around in a particular direction. So for that purpose, to measure this, there is a pointer which is connected to the scale. So this is actually the construction of the PMMC. In the second diagram below, you can see again the top view of the diagram, where the C-shaped permanent magnet is kept U-shaped, between that a coil, a core, and it is pivoted on a jeweled bearing, and it is connected to the pointer. The pointer is kept near the scale, so that wherever the fluctuations will get, the meter will start from 0 to a particular value. It can rotate around all the values. So this is the construction of the PMMC. Now here we can see moving coil instruments working principle. So how does the actual PMMC works, as this is a moving coil instrument? So the basic moving coil instrument working principle is that when a current carrying conductor is placed in a magnetic field, a mechanical force is exerted on the conductor. Okay, so as from the previous figure we can see, when this conductor at the center, you can see the coil, when the current carrying conductor is kept where it is kept between the magnets. So when it is kept between the magnets, their mechanical force will be exerted on the conductor, and this mechanical force will tend to move the pointer around the scale. So the basic principle can also be stated that when a field resultant magnetic field tries to come in line with the main field, thus a deflecting torque is developed. So when the magnetic field is applied and the current is passed through the conductor, the mechanical force will be exerted on the conductor and it will try to come in line with the main field. Okay, so thus a deflecting torque is developed. The deflecting torque will be developed, which will start the pointer to get deflected from its zero position. By the production of deflecting torque, the pointer deflects over the scale. So this is all about the moving coil instrument and its working principle. Now the working of moving coil. When the moving coil instrument is connected in the circuit, the operating current flows through the coil, which is mounted on the spindle. Since the coil is placed in the strong field of permanent magnets, a force is exerted on the current carrying conductor of the coil, which produces deflecting torque. Thus the pointer attached to the spindle is deflected over the calibrated scale. Okay, so similar point is explained here, the process in a single line, that when we apply the input, what happens in the actual system and how the output is received on the receiving end, means on the measuring scale. So I think this point is clear to everyone. Second point is, if the current in the coil is reversed, the direction of deflecting torque will be reversed because of field produced by the permanent magnets remains the same. Okay, we will read this point again because it is very important. If the current in the coil is reversed, the direction of the deflecting torque will be reversed. Okay, it means when we apply the current, okay, in simple way, then the current will start the deflection in the pointer. But if this same current is in the coil is reversed, the direction of the deflecting torque, the direction will be reversed. Why? Because the current in the coil is reversed. So because of the field produced by the magnetic field remains the same. So field will be remained same, but the deflecting torque will be reversed. So this will give a wrong direction of rotation. Thus the instrument cannot be used on AC. Permanent magnet moving coil instrument can be used only for the measurement of DC. Okay, so this is the drawback of PMMC, as we know that if we use the AC current, so in that the direction of the current may change. Accordingly, the deflecting torque will get reversed and the instrument will not work properly. Thus, we cannot use the PMMC for the DC current, AC current. We can only use the DC. So this is the drawback. Now we will see the advantages and disadvantages of PMMC. The advantage is it is having high sensitivity, it is having uniform scale, well shielded from any stray magnetic fields, high torque weight ratio, effective and reliable AD current damping. So all these are the advantages of PMMC. But still, why we need the MI instruments? Because there are also some disadvantages of PMMC. First one is it cannot be used for AC measurement. This is the biggest disadvantage. Second point is it is more expensive compared to the second disadvantage is it is more expensive as compared to moving iron type. And the third disadvantage is aging of control springs and of the permanent magnets might cause error. As we know, two springs are used in this system. So if we have used this instrument a very multiple times, then aging of control springs may happen and which may cause the error. So these are the disadvantages of PMMC. Now we will see the applications. The PMMC which can be used in various ways, like in ammeter, it can be used in voltmeter and so on, in galvanometer also. So we will see one by one. The PMMC has a variety of uses on board ship. It can be used as ammeter when PMMC is used as an ammeter except for a very small current range. Sorry. The moving coil is connected across a suitable low resistance shunt so that only small part of the main current flows through the coil. Now the second point says that the shunt consists of a number of thin plates made up of alloy metal, which is usually magnetic and has a low temperature coefficient of resistance fixed between two massive blocks of copper. A resistor of same alloy is also placed in series with the coil to reduce errors due to temperature variation. Okay, so in this way the PMMC can be used as an ammeter. Now again the PMMC, we can see how it is used as a voltmeter. When PMMC is used as a voltmeter, the coil is connected in series with high resistance. Rest of the function is same as above. So all the functions means how it is connected while using as an ammeter, the same system is used in the voltmeter. Okay, so only the coil is connected in series with the high resistance. Rest of the functions is same as above. The same moving coil can be used as an ammeter or voltmeter with an interchange of above arrangement. So this is how we can use it as ammeter and voltmeter. Now the third application is for the galvanometer. Galvanometer is used to measure small value of current along with its direction and strength. It is mainly used on board to detect and compare different circuits. So this is the application third, and this one is the ohm meter, that is the fourth application. The ohm meter is used to measure resistance of the electric circuit by applying voltage to a resistance with the help of battery. A galvanometer is used to determine the flow of current through the resistance. The galvanometer scale is marked in ohms, and as the resistance varies, since the voltage is fixed, the current through the meter varies. Okay, so this is the fourth application. Actually, this is a construction and a theoretical concept. So it is very easy concept, but you should read and go through it. So we will start in the next lecture with the moving instrument, and in the next lecture we will see the comparative study of MI and PMMC. We will again have an overview about the PMMC in the next video lecture. Okay, so till that, thank you and keep studying.